Okay, Sabrina has a 2.5 gallon container she's going to fill with a 40-to-1 gas to oil mixture. How much does she need to put in the container? Okay, so there's a couple ways to tackle this problem, but what you realize is in the container that's 2.5, that's going to be a total amount. So I could try to figure out my ratio as 40-to-1, but sometimes we like to do the gas or the oil to the total. Okay, so you could set it up 40-to-1 gas to oil, or you could set it up 40 to 41. There's 41 total parts, 1 part oil, 40 parts gas. And the reason I chose to do it that way is because the 2.5 gallon container is going to be the total liquid in there. Okay, so I always, before I do that part, I like to just kind of make, before I do this, I like to say to myself, okay, what does each part of the fraction represent? This is gas, right? And this is total. So I'm not considering the oil in here, but that's okay because I don't need to, because I want to know how much gas I have to put in a container that's a total of 2.5 gallons. Okay, so here is the algebraic equation I need to solve, and I can solve that by cross multiplying. 82. This one I don't have the ratios up here, but this is a kind of a weird one. 4 to 3 to 1. 4 to 3 to 1. This is winds at 20 foot, winds at eye level, and winds at litter level, or on the ground, I guess. Okay, and then, so that's a weird ratio. It's 3 parts, but the question's only going to ask us about 2 of those. So we could use any 2 of these that we wanted. So a report of 20-foot winds blowing at 24. What are the winds at eye level? Okay, so we're just using the 4 to 3 ratio. So 4 is the 20 foot, 3 is the eye level, and then the 24 miles an hour at 20 foot. And then we're asked about eye level. That's the unknown or the variable. Okay, and then solve that for x round, and you're good to go. Remember, we're solving these ratios by or proportions by cross multiplying. All right, so you get 4x equals 24 times 3 dot dot dot, and you'd be done. Okay, 84. When the crew leaves for a fire, they have a full tank of foam. The tank holds a total of 4.8 gallons. When they return, they only have 0.91 left. What percentage of the total is left? Okay, so this is a percentage problem. This is different than the previous ones, and I like to set these up like this. I want to say, okay, what percent is this of the total? So I write a little equation. I say 0.91 is what percent of the total 4.8. Okay, and then I translate that into math, right? Is means equals. What percent is my unknown? We'll call that x, or n, call it x. Of means times, that's a multiplication. So I got 0.91 equals x times 4.8. Okay, so 0.91 equals, I'll rearrange it, 4.8x. And then I can solve this linear equation by dividing both sides by 4.8. All right, and that'll give me, of course, a decimal, and then we'll have to translate that to a percentage.